Hello everyone, myself Gowtham. In this video, let's see hyperparametric tuning of SVM. What is hyperparameter? Hyperparameter is the one that splits the target variable, that is like class levels. In our case, whether a student gets an admitted or not, based on his chance of getting admitted, we are dividing it as if the chance is greater than 50%, that is 0.5, he'll get the seat, else he'll not get the seat. Hyperparameter is the one which splits the data. And what is tuning? Tuning is nothing but, let's see it with an example. Let's see it with and this is the linear regression, and the line equation is y equal to mx plus c. The parameters that change the line is m, that is slope, and c, y intercept. If we change the y intercept and slope, the line looks like this. If we change it again, the line looks like this. For different values of y and sorry, it's not y, m. For different values of m and c, the line look in a different ways, but out of them, the best line that fits our model is the third one. And this is what tuning is. We will select best of our values, that is parameters. We'll give certain values. From those values we will choose the best one. It is called choosing. The use of tuning is we can increase our accuracy of our model without overfitting. Sometimes it might decrease our accuracy, even though, but it it helps us not getting our model overfitted. And let's get into the model. And this is our data. I'm importing models naming pandas, numpy, pre-processing, seaborn. Pandas is used to manage the data frames, and numpy to manipulate the arrays, pre-processing for the normalization, seaborn to visualize the data. And here I'm changing the values, and our output variable is y, that is chance of admitted. I'm changing the values, and after changing the values, this is how it looks, that is 1 1 0 1 0. Here we have only ones, and the number of ones we have is nearly more than 400, and zeros is less than 100. uh, and the next step is pre-processing. We are changing the values from 0 to 1, that we are normalizing the data. Let's see, for for GRS score, here the GRS score is 337, 324, 316, etc. And based on these values, all the values will be changed from 0 to 1, and the TOEFL score also same. And for the CGPA, we are using only three variables, that is GRS score, TOEFL score, and CGPA, and the output variable is chance of getting admitted. And this is our correlation of the data. After using the normalization, that is min max scalar, the values, the GRS score of our first data is 0.94, and TOEFL score is 0.91, and CGPA is 0.9285. And here we are importing the test train split. This is because we can split our data in our ratio we want. Like in this case, we are splitting the data in a ratio of 7.5 is to 2.5, that is 75% of the data is train data, and the test data is 25%. And we are importing the SVM from sklearn, and the kernel I am using is RBF. There will be many kernels, namely linear, polynomial, Gaussian, etc. How RBF works is, from that according to the data, it takes a distance and form a circle shape, exactly not a circle, nearly it's look like a circle, and all the data which plots inside the circle is one type of data, and outside the circle is one type of data, that is, we can say that as target variable. If he get admitted, it will be outside the circle. If he will not get admitted, it will be inside the circle, uh, according to our data. And we are feeding the data in the model, and in this case our accuracy is 94.4. I can say it is a best score, but sometimes the score is not useful because our model might get overfitted, and that's why we are doing here hyperparameter tuning. For hyperparameter tuning, we are importing the grid search. For grid search CV is used, we can give some values like that is parameters. From those parameters, the best value will be extracted, and here I'm giving some C values 0.5 to 1500 and gamma 1 0.3 0.05 0.001, and kernel also RBF and linear. I'm giving two types of kernels. I'm feeding the data here, and here our model is SVC. We imported it from sklearn.svm, and for each C, gamma and kernel, we are getting the score. Out of them, the best parameter will be selected. The best parameter is C value is 100 and the gamma is 1 and kernel is linear. Whereas in the previous, while feeding the data, we gave it as RBF. For tuning the parameter, we gave two kernels. From those, linear is selected, and our score is 94. Even though it is less than our previous score, it is the best score because it prevents us from overfitting. This is how we do hyperparameter tuning of SVM. And thanks.